So back in the early days of the COVID-19 pandemic, while the world was scrambling for answers, a really fascinating scientific puzzle started to take shape. Researchers began to look very seriously at a common, everyday supplement. The big question is, why? What clues led them down this path believing this one molecule could be a key player in the fight? Let's follow the evidence and piece this whole puzzle together.
It became clear really fast that severe COVID-19 wasn't just a lung disease. There was a much deeper, way more complicated battle happening at the cellular level. So today, we're going to unravel this medical mystery together and uncover the pretty stunning two-pronged hypothesis that put this particular supplement right in the spotlight.
To really get the why, you have to remember the when. At the time this research was really picking up steam, the world had already blown past 4 million confirmed cases. The urgency was just off the charts. And that kind of pressure forces scientists to look at every possible angle, not just new drugs, but to re-examine molecules they already understood, really anything that could plausibly help turn the tide. And one of those avenues led them straight to this invisible battle happening inside our cells, a condition called oxidative stress. Now, this isn't some new thing unique to COVID. It's a known problem in a lot of severe viral infections. But with SARS-CoV-2, the sheer scale of this battle was, well, it was unlike anything they'd really seen before.
So, to put it simply, oxidative stress starts with the very oxygen we breathe. As our body uses that oxygen for energy, it creates byproducts, kind of like exhaust fumes from a car's engine. Some of these byproducts, like superoxide and these things called hydroxyl radicals, are super unstable and can really bang up our cells. Scientists call these little troublemakers reactive oxygen species.
Thankfully, our bodies are not defenseless. We have this amazing system, and its MVP is a molecule called glutathione. You can think of it as a cellular superhero. Its whole job is to constantly swoop in and neutralize these damaging free radicals, keeping our cells safe and everything in balance.
And that delicate balance is precisely what the virus went after, creating what researchers started calling a perfect storm. By messing with the ACE2 receptor and kicking off this massive immune response, the virus basically opened the floodgates for superoxide. This absolute onslaught just rapidly burned through the body's supply of glutathione, leaving our cells totally exposed and defenseless.
So if your main defense system is getting wiped out, what's the most logical thing to do? Well, you try to rebuild it, right? You send in reinforcements. And that exact line of thinking led researchers to our molecule of the hour, N-acetylcysteine, or as it's more commonly known, NAC. Now, here's the key thing to understand. NAC itself isn't really the hero of the story. It's more like the hero's supplier. It provides the essential raw material, an amino acid called cysteine, that our bodies absolutely need to manufacture more of that master antioxidant, glutathione. It's kind of like sending a convoy of supplies to a factory so it can rebuild its shields. And look, this wasn't some wild shot in the dark. NAC has a really long, established track record in medicine. For years, it's been the go-to treatment for a Tylenol overdose, where it works by, you guessed it, replenishing glutathione in the liver. It's also used to break up thick, nasty mucus in the lungs. So the point is, this was a known quantity. It was a tool they already had in the toolbox.
And there was even some history to back this all up. A really interesting study on the flu from way back in 1997 found something remarkable. Get this. NAC didn't actually stop people from getting infected with the flu, but it made a massive difference in whether they actually got sick. Only about 25% of the people taking NAC developed symptoms, compared to almost 80% in the placebo group. That's a huge difference. It suggested NAC helps the body handle a viral attack without getting completely overwhelmed.
Okay, so at this point, the story seems pretty simple, right? Fight oxidative stress with NAC, and maybe you reduce how bad the illness gets. But then, a new and, frankly, terrifying piece of the puzzle emerged from hospitals all over the world.
Because what if that whole oxidative stress storm was only half the story? What if it was just the trigger for something even more immediately dangerous?
What doctors were seeing right there on the front lines was that severe COVID was also a vascular disease. Patients were developing these dangerous blood clots, thrombosis, in their lungs, in their brains, all throughout their bodies. This wasn't just some side effect. For many, this was the thing that was proving so deadly.
And it turns out the main culprit behind all this clotting was a protein called von Willebrand factor, or VWF. When that oxidative stress damages the inside of your blood vessels, the body just unleashes these massive, super long, stringy chains of VWF.
And they act like this incredibly sticky molecular Velcro, just grabbing platelets and forcing them to clump together into these dangerous clots. And that's when the whole investigation took this incredible turn, because as it turns out, NAC has this secret second act, a hidden superpower that scientists had actually been studying for years, completely unrelated to its antioxidant role.
Okay, and to get this next part, we have to take a weird detour and talk about getting a perm. Seriously, stick with me here, because the secret behind both curly hair and dangerous blood clots is this tiny but incredibly strong chemical bridge called a disulfide bond.
So when you get a perm, they put a chemical on your hair called a reducing agent, and its job is to snap all those little disulfide bonds that give your hair its natural shape. Once they're broken, the hair can be reshaped. Then they add an oxidizing agent to reform the bonds and lock in the new curl. But that first step, that's the whole secret. A reducing agent has the power to break disulfide bonds.
And that is the mind-blowing connection. This is NAC's two-for-one punch. On one hand, yes, it's an antioxidant booster, providing the fuel for glutathione. But on the other hand, NAC itself is a powerful reducing agent. This means it could theoretically just go in and start snapping apart the very disulfide bonds that hold those dangerous, stringy von Willebrand factor clots together.
And check this out. This wasn't some new idea they cooked up during the pandemic. This quote is from a major paper in the journal Circulation from 2017. Years before COVID-19 even existed, researchers were already suggesting that NAC could cleave, which just means split apart, the VWF inside occlusive thrombi, which is just fancy talk for big blood clots that block up your vessels. The idea was already there, just waiting.
Okay, so let's take a step back and put all of these puzzle pieces on the table. When you lay it all out, you get this really elegant two-pronged hypothesis.
So here's how it all plays out. The virus comes in and causes two big problems at once: oxidative stress and the release of that clot-forming VWF. This leads to the twin dangers of cell damage and thrombosis. The theory was that NAC could potentially intervene on both of these pathways at the same time, boosting glutathione to protect the cells and directly breaking those bonds to dissolve the clots.
So that was the full scientific rationale. That was the why. It wasn't just about NAC being a simple antioxidant. It was this incredible idea that one single, well-known molecule could potentially fight the two defining features of severe COVID-19, that oxidative firestorm and the deadly blood clots. And of course, a beautiful hypothesis like that leads to the most important questions of all, the ones that could only be answered by clinical trials. Could taking NAC as a simple oral supplement actually prevent people from ever getting severely ill, kind of like in that old flu study? And for patients already in the hospital, already critically ill, could high doses of IV NAC act as a clot buster and actually save lives? These were the questions that researchers had to answer next. And that's where this part of the story ends, and the next crucial chapter of science had to begin.